compute the derivative of the function y is equal to parenthesis opens 1 plus 2 sin x plus 3 cos x, all close e to the power of x. Now, in this problem, we have our derivative in itself has so many rules. Alright, we have the power rule, we have the product rule, we have the quotient rule, we have the chain rule. But in this problem, which rule do you think exactly we have to apply here to make this problem to be solved with ease? Alright, so here we say we have to apply the product rule. Here we're going to apply product rule. So let's take it from here, put it here, product rule. And then the product rule says is equal to f prime x g of x plus f of x g prime x. Alright, this is the product rule. Alright, so that means in this problem we have to apply this rule to enable us to get this problem solved easily. So we make this first one f of x, y prime of x is going to give us f of x. If we say this is going to give us f of x, this is that thing, f of x. So that means we're going to have 1 plus 2 sin x plus 3 cos x prime. F of x is prime over there. Alright, so e times this times e to the power of x. Alright, let's write this clear. Plus, and then the next term over there is what? Is g of x. So g of x is this term. Alright, so now let's get the next step. So here we still going to have parenthesis opens 1 plus 2 sin x plus 3 cos x. We're going to have cos x. Yes. Times e to the power of x. So this is raised to the prime. Alright, so now in this, that means in this term we are going to differentiate here. Or leaving this. So that means here we are not going to touch this, but we are going to differentiate this term. That's it. That's the product rule. So now that means here we're going to have y prime of x is going to give us the differential of 1. That means you multiply by 0. A constant is equal to 0. Alright? So now that means we're going to have 0 plus this the differential of sin x. This is a coefficient to sin x. So we hold this constant, so that means we're going to have 2. This constant, so that means we're going to have 2. The differential of sin x gives us what? Cos x. Alright? Now the next one. Now the differential of cos x gives us negative sin x. Alright? So that means we're going to have minus 3 sin x. Alright? Times e to the power of x. Now the next term, let's get to it. So that means we're going to have plus. What's here? We're going to write all this down as we are seeing it. Sin x plus 3 cos x times the differential of e to the power of x is an exponential function. Alright, so the remaining constant, that's the same term. So that means we're going to have the differential of e to the power of x is e to the power of x. Alright, so now we have gotten this. What do we do here next? The only thing we're going to do is to collect our light and combine the two equations. That's it. So here now we're going to have y prime x is going to give us, alright, so we have 0 here, and then we have 1 here. So 1 plus 0, so let's just combine them, alright, as we are saying it. We're going to have 0 is 0, 0 means nothing. Alright, so let's take this. 2, we're going to have 2 cos x. 2 cos x, what's another? Okay, plus 3 cos x. Okay, and then the next term here is sin x. So we're going to have minus 3 sin x. And then the next function that is the sin here and the sin here will combine them. Alright, we add them. So that we're going to have plus 2 sin x. Alright, so plus 1, this one. Now multiply by e to the power of x. We know that yes, this one is multiplied by e to the power of x, and then this one too is multiplied by e to the power of x. So we are only going to choose one of the e to the power of x. Alright? So now let's go. Y prime of x is going to give us, now here we're going to have 2 plus 3 give us 5. 5 cos x. Alright? So this, and then positive 2. This is going to give us minus, this is going to give us minus sin x. Minus sin x, and then plus 1, all multiplied by e to the power of x. Guess what?